how about you guys try this one here? So write a function that converts temperature in Celsius to Fahrenheit, and it's related like that. So C here represents Celsius, and F is definitely Fahrenheit. And I want you guys to test the function with C is 15, and have your function name as this F underscore C to F. By the way, you don't really need to have this F underscore. This is just my convention. You can have my C to F or C to F or F C to F function C to F. It's all okay. And this is just my convention, like I said. The only reason why I have it like this is later on in the workspace, if you have multiple main functions and main files that runs the function, and if you had multiple functions there, and if you don't have this under f underscore, sometimes you get confused. Oh, is this a function or is this a main file? Of course, these icons look slightly different. This here means it's a function, but it's just my convention. I prefer just having f underscore as like a prefix of the name of the functions files. Okay, so anyway, in this case, I want you guys to have the function name as this, which will receive numbers in Celsius as an input, and will create numbers in Fahrenheit as the output. Let me give you a little bit of time to work on this. All right, let's try this thing together. So here, if you were to run this thing in the main workspace, you might just type in like that right here. So C is, let's have a capital C is 15, and F is 9/5 times C plus 32. Okay, yeah, definitely you can run it like that. And if you run it, you're going to have F and C showing in the workspace, just like that, right? Or if you were to create a function, you want this calculation to be done in the function space, right? So instead of having it up front like that, what we'll do is we'll create another function, another file here. So function, and we need to have an output. And in this case, it's going to be the Fahrenheit, right? And the function name was what? F underscore F C to F, right? And then it receives the input in Celsius. And we end this guy, right? And what we do is we're going to run this calculation inside the function instead of having it over there. So it will receive the C. C is going to be used inside here to get the F, and F is going to be my output, so it will go out. Okay. Again, this you can just have it as in, and you're using it, and you can have it as out, and you're putting it as out like that. Totally fine. Okay, as long as it is used at the right place and like this. All right, and remember, you need to save this thing. And when you save it, make sure that it is saved. The file name and the function name, they're basically the same. And you save it like that. It shows up in the current folder, right? And now we can just run this guy in the main file. So F underscore C to F, and you provide the C. You run it like that. See? Get the same value, 59. Or I can put it in SF, just like that. So C is 15, F is 59, right? Straightforward. Okay, any questions up to here? If not, let me give you a little bit of time. And how about you guys work on this? All right, let's try this thing together. So just like before, if we were to run this thing up front in the main workspace, then you just type in R is 5 and the circumference is 2 times pi times R. That's it, right? However, if you want to use this thing as a function, then this calculation, which is 2 pi r, will be done in a separate file. And in that separate file, we are defining this as a function, right? And this circ is going to be the output variable, so it's within the brackets, is equal to f underscore circ. That's the, oh, function name here. I gave it as circle. Let's just change it like that. Totally fine. So this is going to be the file name as well, right? And then you're receiving the R. R is being used down here to calculate circ, and circ is going out. So what happens is number 5 goes into this function, right? And that goes in here. So from now on, R is going to be the number, R is going to be number 5, right? And that is used down here to get this CIRC, the circ, and this is going to be the output. So it comes out here, and that's again assigned to this circ. All right, so instead of running this up front in the main workspace, you can push this thing into the function and have this thing calculate there and just spit the output back here. Okay, all right, let's move on. And how about you guys try this one here? So I want you guys to write a function that finds the volume of a cylinder with a height of 2 meters when radius is given as an input. Okay, and I want you to test the function with radius r is 0.5 meter. And the function name, we have f_vol, and it receives radius as an input, and it will generate an output, which is the volume. So if we were to run this thing up front in the main workspace, r is 0.5, right? H is 2, just like the height given as 2, right? And then the volume is going to be pi r squared, the base area times the height, right? So that's going to be our volume. And if we run this thing in the main workspace, we're going to have R, H, and vol shown up in the workspace. Try it here. Run this guy. We have H, R, and vol all shown up in the workspace, right? However, if we create a function, it will be like this. So instead of running it up front in the main workspace, we will create a separate file, right? And inside here, we're providing 0.5. So 0.5 will go inside to the function called fvol, f underscore vol. And then that 0.5 is assigned to a variable called r. And this r, inside the function, we're defining this h as 2. And we're using h and r to get the vol, and volume vol is the designated output, so it goes out, and then it will be out in the outside of this workspace. So if we were to run this thing, instead of running this, we were to have this, and if we create a function, let me just copy this guy to save a little bit of time. We need to save this, and fvol is what we have. So if we run it, currently we have 3 variables. Now only this vol shows up in the workspace. Okay, so the important thing here is what? This h is equal to 2, or the r. Those are local variables, so it will not show up in the main workspace. Okay, all right. And this is just like, we talked about this. Where is that? The kitchen. So only the food that we order comes out, not the crumbles or any batter or any leftover. Those aren't going to just stay inside the kitchen. So local variables are just like that. Okay. And let me give you a little bit of time. And how about you guys try this problem here? So I want you guys to write a function that calculates the circumference and the area of a circle when a radius is given as an input. And I want you guys to test that function with a radius r is 5. And the function name is fCircle. So it receives a single input, which is the radius, and it will generate two output variables, values, which is the circumference and the area. Okay? All right, let's try this thing together. So if we were to run this thing up front again, r is 5, and we're using this to get the circumference. Let's call it a circ. 2 times pi times r, and to get the area, it's pi r squared, right? So if we ran this thing, run just like that, we're going to have a, circ, and r all shown up in the workspace, right? However, if we create a function, now we're going to have two outputs, see? Circ and area. So within the brackets, we're going to have these two as our output, right? And we're going to have one input that is going into the function within the parentheses. So this number 5 will go inside the function, and it's going to be assigned to this variable called r. And this r will be utilized to get this circ and a. And you see, circ and a are the variables that are designated as our output. So these will go outside of the function, and it's going to be assigned over there. So we run this thing. We need to create another function, right? So here we save this thing, save as fCircle, they are the same, save it, and now we're running this. So instead of having these, and this guy, see, circ a, are going to be shown up there, having the same value. Okay. Any questions? So here, this is going to be the bonus homework that I want you guys to try. So I want you guys to write a function that calculates the height and the velocity of a projectile at a given time. And t is in seconds, okay? And this is going to be our input. And the projectile is launched vertically from ground. Elevation is 0 with a velocity of 20 meters per second. Okay, and assume the acceleration due to gravity is 9.8 meter per second squared. And the elevation is obtained, h is obtained like that. Note that v naught is our initial velocity, which is 20 meter per second. Let me make it like that. And g is going to be our gravitational acceleration, which is 9.8 meter per second squared. And test the function, okay, with, no, again, this is time. T is 1.2 second. And I want you guys to have the function name as f underscore projectile. It will receive time as an input, so single input, and it will generate two output values, which is the height and the velocity of the projectile, which is h and v in this case. Okay? All right. Okay, that's it for today. I hope you guys enjoy the break, and I'll see you guys next week. Thank you.